I'd like to share with you a few tips now about analyzing a large number of files. I'm going to use the example of images here, but this can be done with any type of file, any list of files, because we're doing it on a large scale. So just to give you an idea, these are my files. These are a bunch of images, basketball players, and as you can see, some are 8 kilobytes, some are 7, 59. Etc. And you can see from here that we have almost 1,200 files. So it's difficult to do this by hand, one by one. So the OS module in Python has a stat function, which runs a system stat call, whatever. And it gives us some information about the file that we ask it for. Okay, so here's, this file has a mode of this, stdev, stnlink. The interesting ones, for me at least, are the size. This is the size of the file and a bunch of time attributes. So a time, access time, when was this file last accessed? st_m time, when was this last modified? So if you want to check the files that have been modified 3 days ago, 4 days ago, a month ago, whatever, and the creation time. So these are going to be very interesting things for us. So just to make this slightly more usable, I created a function called it file info, and it does pretty much the same thing, but a little bit more detailed. So once you run this function on any file, it gives you all the information as a dictionary, so it's easier to use, and it gives you the file path itself here, so we can keep track of it to use later. So once we filter for a certain size or a certain creation time, we want to know which are those files. So running this for the whole list of files we have, the function is called file info. Run it on every file for file in os.listdir, list directory, list all the files in this directory, but only if the file ends with .png. Okay. So what this does is goes through every file, runs this function, and gives us a list of dictionaries for each one of these files. And we can run the data frame function here and create a data frame of this. So what we have now is a large table. Well, not large, but as many PNG files as we have, with all the information in columns. So before analyzing, I want to just do some processing with the times over here. Let's take an example of the a time. So let's take a look at one of the values. So this file was last accessed at this time. Now, if you're not familiar with Unix time system, this is the number of seconds from 0 o'clock, the 1st of January 1970. This was the convention. So Pandas knows how to deal with this. There's the to-date time function, and we're going to give it this column, and we just have to say that the unit here is seconds, or it could be nanoseconds or something else. So now that looks much more usable. So this is the number of seconds from January 1st, 1970 to when the time was when the file was last accessed. It looks right, 2024 0513, and we have the same number, the fraction of seconds over here. Okay, so now I'm going to go through a loop on all these columns over here. If the column contains time, then we're going to convert it to date time, and the unit is going to be ns. If the column ends with ns, which means nanoseconds. So apparently it gives you both options, because in some cases you want to go that granular, or seconds. So now our data frame looks much more usable. Okay, we can easily look at these and understand them, and now we can do some analysis. So let's take a look. I'm going to make a histogram of this data frame. And taking the st_size attribute. Okay, now that's very interesting. So the file sizes seem to be grouped in two clusters. Very small files here are between 5 kilobytes and 10 kilobytes, and the rest are clustered between 40 kilobytes. So there's a big difference in size. So now you can, maybe these are thumbnails or these are large, high quality images, whatever you want to use. And now we can easily filter. We can say, give me DF, where DF size is less than 20,000. Here are the files that are less than 20,000. We have 501 rows, which is exactly the number here. And now we can say, just give me the file path and st_size. And now we have a nice report giving me every file, its size, and the file path. You can add more columns here if you want. Another thing we can do is, let's make this a bit more usable. File size distribution. Okay, and let's change this label on the x-axis from st_size to file size. Okay, and let me make the height a bit more, let's say 500 pixels. Okay, that looks better. Okay, I'm going to copy and paste this same code so we can reuse it here. And I'm going to say the birth time of the file. Okay, let me just modify file birth time distribution, and st birth time is file birth time, just so it's clear, and birth time. Interesting. So we have three clusters actually of files. Some of them were created between May 12th, 15 hours and 1529, and the other were created in this time period. So I just copied and pasted this code. What about the access time? Okay, is this any different? And I'm going to change this to access time. Okay, it seems it is different. So we have two clusters. We have 142 files that were accessed or opened in this period, and the others were accessed this time. So you can filter by access time, by size, by creation time, and so on. So this was a quick overview of what you can do. What we did is create a simple function that takes the file path, creates it into a dictionary, run this on a list of files with a filter of PNG, create this data frame, do some date-time conversions, so we have an actual date-time object here instead of number of seconds and nanoseconds, and now we can easily see the distribution of sizes, get a subset that we want, access time, creation time, and whatever we want. Yep, that's it. I hope you liked it. Thank you very much.